When a body slide down from wrist, when a body slide down from wrist along smooth inclined plane, along smooth inclined plane, making an angle of 45 degree with the horizontal, with the horizontal. It takes time, capital T. It takes time, capital T. When the same body slide down from wrist, same body slide down from wrist along the rough inclined plane, making the same angle and rough same distance. It is seen to time take P into T. It is seen to time take P into T. Okay. So let us suppose a body which is slide down on an incline. A body is slide down on an incline. Angle will be the 45 degree. If that body on slide on the smooth inclined plane, the angle of inclination which will be equals to 45 degree, and time taken for the smooth inclined plane which will be the capital T. If the same body, same inclination and same length, same body, same inclination, same length, then time taken will be the P into T. But between body and surface, between body and incline, the smooth surface cannot be exist. There is the or rough surface will be exist. Okay. So we have to calculate the value of coefficient of friction mu. Okay. So we have to calculate the value of coefficient friction mu. We are trying to find out the, we are trying to construct the figure which is as shown in given. Let us suppose this is the body, this is the body, and this inclination equal to a 45 degree. Any length, let us suppose this is the A point, B point. If a body slide from these situations downward, if mu equals to 0, if coefficient of mu equals to 0, then time taken from capital A to capital B position, which will be equals to capital T. If coefficient of mu equals to 0, if coefficient of mu equals to 0, there are the two positions. If coefficient of mu equals to 0 means for a smooth surface, the time taken T1 equals to capital T. If coefficient of mu cannot be equal to 0, then time taken T2 equal to P into capital T, where P is the any constant which is greater than 1. So we have to calculate the value of a T, mu. So we have to calculate the value of a mu. We have to calculate the value of a mu, but angle theta is the given. Theta is the inclination angle. Theta equals to a 45 degree. We have to calculate the value of a angle theta is the 45 degree. So we are trying to find out the accelerations A. Let us suppose for first condition, the coefficient of frictions, for first condition the coefficient of frictions mu equal to 0. Let's suppose for first condition mu equal to 0. Mu equal to 0 means this is the smooth surface. Mu equal to 0 means this is the smooth surface. Okay? So you can say this is the mass m. So this is the mass m. This is the mg, vertically downward. Angle theta equal to 45 degree. So this angle will be the 90 degree. So this will be what angle? This angle must be a 90 minus 45 degree. This angle must be a 90 minus 45 degree. Okay. So this angle is the 90 minus 45 degree. So 90 minus 45 degree, 90 minus theta, let us suppose this is the theta angle. So mg, so this component must be mg into cos of 90 45 degree. Cos of 90 45 degree, the cos of 90 minus theta. Mg cos of 90 minus theta. So cos 90 minus theta equals to sin theta. So along inclinations, the force will be the mg into sine of a theta. But this is the mg into sine of a theta because this is the sine of 90 minus theta. If sine of 90 minus theta, so mg into cos of a theta. So mg into cos of a theta. Mg sine theta finally along the inclinations and perpendicular to the inclination, which will be the mg into cos of a theta. This is the mg into cos of a theta. This is the mg into sine of a theta. This mu equal to 0. So along the inclinations, only one force will be acted, which is the mg into sine of a theta. Mass m is the given and acceleration a is the given. So along the inclinations, acceleration a is the given. So according to Newton's second law, F net equals to m into a. F net equal to m into a. So on small m kg, this is the force mg into sine of a theta, which is the down the incline. So mg into sine of a theta equals to m into accelerations a. So according to the Newton's second law, mg into sine theta equal to m into a. So mg into sine of theta equals to m into a. Cancel the value of a. Accelerations a equals to mg into sine of a theta. If coefficient of friction mu equals to 0 or for a smooth surface, the accelerations of the body which will be equals to g into sine of a theta. Okay. For these situations, acceleration a equals to m. Acceleration a equals to g into sine of a theta. Okay. Acceleration a equal to g into sine of a theta. So for first conditions, if mu equal to 0, accelerations a equals to g into sine of a theta. Theta angle, theta is the given. Theta value equals to 45 degree. This theta equals to 45 degree. So from A to B positions, we are using the value of kinematics equations, which will be s barabar ut plus half d square. S barabar ut plus half d square, because we have to find the value of coefficient of friction mu in terms of a p and t, because p and t given and in terms of a theta. So we are using the kinematics equations. First, v equal to u plus at. Second, s barabar ut plus half d square. Third, v square equals to u square plus twice s. So from A to B, s barabar ut plus half d square is the best to find out the coefficient of friction mu. Okay, because this if mu cannot be 0, so also you can calculate the value of accelerations a. So as length is the same, AB will be the same, because in these questions AB length is the given. AB length will be the same length. This length is not given. So for mu equal to 0 and for mu cannot be equal to 0, for a smooth or rough surface, the length AB which will be equals to same. So AB equals to for ut plus half d square, and for second ut plus half d square, that must be same. Okay, so we are using the s barabar ut plus half d square, using the ut plus half d square. But in theory, the given point for both situations, if mu 0 or not 0, then that block from top positions which will be from the rest. Okay, so velocity equals to 0, imply that velocity equal to 0. So s equals to 1 by 2 accelerations a equal to g into sine of a theta into t whole square. The tension t is the given, accelerations time t from A to B, time taken from A to B for a smooth surface, which will be the capital T. So that value will be given. So s equals to 1 by 2 g into sine theta into t square. So this is the AB length is the given length. This is the AB length. Now we are construct the for second positions, for second situations, if mu cannot be equal to 0. If mu cannot be equal to 0 for second positions, mu cannot be equal to 0. Angle theta 45 degree, mass m, let us suppose, so this will be the mg into sine of a theta, and this will be the mg into cos of a theta. This is the mg into sine of a theta, and this value will be the mg into cos of a theta. This angle theta equal to 45 degree. So you can say we are trying to find out the accelerations A. If mg into sine of theta is acted in down the incline, so mu cannot be equal to 0. Let us suppose coefficient of friction mu, coefficient of friction mu. So mg sine theta down the incline, so opposite to the net force. If let us suppose m mass body, if any person which is acted force F right hand side, so friction force, if body will be the move, then kinetic friction will be acted the opposite to the external forces. Okay, so here mg sin theta is the external forces, so these forces will be act down the incline, so friction force will be acted upward to the incline. Let us suppose this is the kinetic friction. If body will be moved, then friction force must be a kinetic friction. If body cannot be moved and not a tendency, then no any friction force will be acted. If body cannot be moved but that body tendency, so we can say that that friction force are acted the static friction. Static friction is always variable frictions. Kinetic frictions are not a variable frictions. So static friction will always act from 0 to Fs max. Fs max will be fixed, which will be equal to mu s into n, but kinetic friction which will be equal to mu k into n. So in this portions that will be the Fk. Fk is what? So Fk, you can say Fk equal to mu k into n, because this body will be moved downward directions. So kinetic friction will be acted. So normal actions n. N will be what? N equals to. We are trying to find out the ability for the situations. This is the normal actions n. So n equals to mg into cos of a theta, because the body cannot be moved the perpendicular to the incline. So n equals to mg into cos of a theta. Okay. So net body moves the down the incline, imply that mg sin theta minus fk. mg sin theta minus fk equal to m into a. We have to find out the value of accelerations A for the rough surface. Okay, so mg into sin of a theta minus fk. Fk is the mu into n. N will be what? Mg into cos of a theta, which will be equal to m into a. So cancel the value of m. So a equal to g into sin theta minus mu g into cos of a theta. So accelerations A equals to g into sin theta minus mu g into cos of a theta. Now we are using the kinematic second equations as per our ut plus half at square. S equals to u. For both situations, initial velocity will be a 0. This value is given in the questions. will be equal to 1 by 2 s less than a. S less than a is the given that number, which will be the g into sine theta minus mu g into cos of a theta into t. T will be what? In these questions, for a rough surface, tan t equal to p into capital T, which will be the square. Okay. So as length will be same for that situations, so this will be the for smooth surface length. Imply that you can say then that number equal to 1 by 2. This number 1 by 2 g into sine theta into t square. So t square will be a cancel out. P into t whole square in p square into t square. So we can calculate the value of a mu, and also g will be cancelled out. Okay. So we are trying to find out the value of mu. Mu will be what? So this will be 1 by 2. 1 by 2 also will be cancelled out. So this number is the p square mu into cos theta. This will be the p square mu into cos of theta. P square mu into cos of a theta. So this number is the shifted the left hand side. Okay. Here sine theta, and this number is the sine theta, and this number what will be the value? This will be t square sine theta. This was sine theta, or here p square into sine theta. And that we can say p square into sine theta and minus sine theta, and that value which will be the sine theta. Okay, because 1 by 2 will be cancelled out, also g number in both, because this is the minus sign is given, so g will be cancelled out, 1 by 2 will be cancelled out, imply that this will be the p square into mu into cos of a theta, which will be equal to, this will be the sine theta, this will shift to right hand side due to minus, this is the plus, imply that number. So theta equal to 45 degree. Theta equal to 45 degree. So theta equal to 45 degree. So sine 45 equal to 1 upon root 2. Cos 45 equal to 1 upon root 2. So sine theta 1 upon root 2, 1 upon root 2 and 1 upon root 2. Because theta equal to 45 degree. So 1 upon root 2, 1 upon root 2, 1 upon root 2. Minus is given. So sine theta, these numbers are cancelled out. Imply that mu equal to p square minus 1 divided by p square. So this will be the value of mu.